So this is another system of linear differential equations. For this system, since we know how to find eigenvalues and eigenvectors, I will skip over most of that. However, this one's slightly interesting because we will have a repeated eigenvalue, and that repeated eigenvalue will have two eigenvectors associated with it. So this matrix here is A. I will go ahead and tell you the eigenvalues of A are lambda is -1, and lambda 1 is -1, lambda 2 is 2, and that eigenvalue occurs twice. So for lambda is -1, we have v, or k, rather, our eigenvector, k1 is 1, 1, 1. For lambda 2, let's go ahead and find that. So we'll say a minus lambda 2 I bar 0 will give us, since lambda 2 is 2, so a minus lambda 2, the diagonal will be -1s, and actually every element of this matrix will be -1. So we'll have -1, -1, -1, -1, -1, -1, -1, -1, -1, bar 0, 0, 0. And so here, of course, we can actually eliminate 2 rows. And so we will do a sequence of row operations. Basically, all we'll do is multiply the first row by -1 and then add it to the other 2 rows. And that will give us 1, 1, 1, 0, 0, 0, 0, 0, 0, 0, 0, 0. And so what this says is that k1 plus k2 plus k3 equals 0, but it gives us no other information. And so we can construct two linearly independent eigenvectors from this same eigenvalue, from this same equation. We can say, let k three equal 1 and k2 equals 0, and that will give us the eigenvector k2, which will be -1, 0, 1, and then we can say let k2 equal 1 and k3 equals 0. That will give us the eigenvector k3, -1, 1, 0. So we can get both of these eigenvectors from this one eigenvalue, and they're linearly independent. So since these eigenvectors are linearly independent and we have 3 eigenvectors, we can diagonalize this matrix. So let's go ahead and do that. We already know all the steps we need to do, so we can just start blindly computing things, since we've done all the algebra a whole bunch of times before. So we know that we will have y prime is dy, and in this case, that will give us the 3 uncoupled differential equations. Y1 prime is, let's see, lambda 1 was -1, so negative y1, y2 prime will be 2y2, and y3 prime will be 2y3, 2y3. And then if we solve these, we will get y is c1 e to the minus t, c2 e to the 2t, e to the 2t, and c3 e to the 2t. And so, From here, we have y, so we can form x by x equals p y. And so let's see, what order do we have? So we had, this is k1 and this is k3. So p will be, what was k1? k1 was 1, 1, 1. So 1, 1, 1, negative 1, 0, 1, negative 1, 1, 0. This is p. So x will be, if we write this out in sort of a matrix algebra form, we'll have x is c1 e to the minus t times 1, 1, 1 plus c2 e to the 2t times negative 1, 0, 1 plus c3 e to the 2t times negative 1, 1, 0. And this is the solution to our system of differential equations.